Our next guest is another great friend. Supermicro and AMD have been working together to bring leadership computing solutions to the market for many years based on AMD processors as well as Instinct accelerators. Here to tell us more about that, please join me in welcoming CEO Charles Liang to the stage.
Congratulations.
Thank you so much. Hello, Charles.
Successful launch.
Yeah, thank you so much for being here. I mean, Supermicro is really well known for building highly optimized systems for lots of workloads. We've done so much together. Can you share a little bit about how you're approaching Gen AI?
Thank you. Because our building block solution based on a modularized design, so that enables Supermicro to design product quicker than others and deliver product to customer also quicker, better leverage inventory, and better for service. And thank you for that close relationship. Thank you for all the help. So that's why we are able to design product, time to market as soon as possible.
Well, I really appreciate that our teams also work very closely together. And we now know that everybody is calling us for AI solutions. You've built a lot of AI infrastructure. What are you seeing in the market today?
Oh, the market continues growing very fast. The only limitation is...
Very fast, right?
Very fast. Maybe more than very fast. So all we need is just more cheap. More solution.
I
So
know.
today, including USA, Netherlands, Taiwan, and Malaysia, we have more than 4,000 rack per month capacity. And customer facing to not enough power, not enough space problem. So with our rack scale building block solution with free air cooling, optimized for hybrid air and free air cooling, optimized for liquid cooling, that can help customer save energy power up to 30 to even 40%. And that allow customer to install more system with fixed power budget. And or same power, same system, but less energy cost. So all of those together with our rack scale building block solution, we installed a whole rack, including generative CPU, GPU, and storage, switch, firmware, management software, security function. And when we ship to customer just simply plug in two cable, power cable, data cable, and then ready to run, ready to online. For liquid cooling customer, for sure they need a water kind of tube. So that make a customer can easily online with one chip available.
Yeah, no, that's fantastic. Thank you, Charles. Now, let's talk a little bit about MI300X. What do you have planned for MI300?
Okay, the big product line. We have a product based on MI300X, right? AU for air cooler or free air cooler, and then 4U optimized for liquid cooler. So the air cooler per rack, we support up to 40 kW or 50 kW. For liquid cooler, we support up to 80 kW or 100 kW. And so all kind of rack scale, plug and play. So when customer need, once we have chip, we can ship to customer quicker.
That sounds wonderful. Well, look, we appreciate all the partnership, Charles, and we will definitely see a lot of opportunity to collaborate together on generative AI. So thank you so much.
Thank you so much for the support. Thank you.
Okay, now let's turn to our next guest. Lenovo and AMD have a broad partnership as well that spans from data center to workstations and PCs, and now to AI. So here to tell us about this special partnership, please welcome to the stage Kirk Skaugen, EVP and President of Infrastructure Solutions Group at Lenovo. Hello, Kirk. Thank you so much for being here. We truly appreciate the partnership with Lenovo. You have a great perspective as well. Tell us about your view of AI and what's going on in the market.
Sure. Well, AI is not new for Lenovo. We've been talking and innovating around AI for many years. We just had a great supercomputing where we're the #1 supercomputer provider to the top 500. And we're proud that IDC just ranked us #3 AI server infrastructure in the world as well. So it's not new to us, but you were at Tech World, so thanks for joining us in Austin. We're trying to help shape the future of AI from the pocket to the edge to the cloud. And we've had this kind of concept of AI for all. So what does that mean? Pocket meaning Motorola smartphone AI devices, and then all the way to the cloud with our ODM Plus model. So our collaboration with our customers is really to accelerate AI adoption. And we recently announced another $1 billion to the original $1.2 billion we announced a few years ago to deliver AI solutions to businesses of all sizes, from the smallest business to the largest cloud. So we believe that generative AI will ultimately be a hybrid approach, and fundamentally, we do want to bring AI to the data. I think one of the most exciting things for me is, I think like Arthur said, right, we see data doubling in the world over the next few years. 75% of that compute is moving to the edge, and today we're only computing 2% of it, so we're throwing away 98%. So more data is going to be created in the next few years in the entire history of the world combined, and together, we're bringing AI to the edge with the recent SE455 ThinkEdge that we announced. We think that there's kind of 3 views of generative AI: public AI, private AI, and personal AI. And the key for us is protecting privacy and addressing data security. So public AI, where you'd use, obviously public data; enterprise AI, where you'd use only your enterprise data within your firewall; and then on things like an AI PC, things that you choose to have only on your device, whether that's a phone, a tablet, or a PC.
Yeah, no, it's a very comprehensive vision, and we see it very much the same way. Now, you talked a lot about your AI strategy at Tech World, and you had some key pillars there. Do you want to just tell us a little bit more about that?
Yeah, so I think there's 3 fundamental pillars of our AI vision and strategy. First, we have an AI product roadmap, I think that's second to none, from a rich smart device portfolio, and we'll talk about AI PCs probably more in another day, smartphones and tablets. Then we have a huge array now of over 70 AI-ready server and storage infrastructure products. And then we've recently launched a whole set of solutions and services around that as well. So more than 70 products, and we'll talk about the new ones we're announcing today, which are very exciting. The second thing is we have something called an AI Innovators Program. What's really daunting to people is there's over 16,000 AI startups out there. So if you have an IT department of a few dozen people, how do you even start? So we've gone and scoured the earth. We've found 65 ISVs, 165 solutions where we've optimized them on top of Lenovo infrastructure for some of the key verticals, and are delivering kind of simplified AI to the customer base. And then at Tech World, we launched a comprehensive set of professional services. Now Lenovo, more than 40% of our revenue is non-PC, so we're transforming into data center and services. So we're doing everything in the AI, from just basic customer discovery of what you can do if you're a stadium, what are the best-in-class stadium solutions if you're a fast food chain, if you're a supermarket, all the way to AI adoption, and then even from a sustainability perspective, things like asset recovery services to make sure you have a sustainable AI journey as well.
Yeah, no, it makes a lot of sense. And Gen AI and large language models are like sort of the defining moment for us right now. You're spending a lot of time with customers. What are you hearing from them, and what are their challenges?
Yeah, so I think the key message is that customers need help in simplifying their AI journey. I mean, there's so much coming at them. So our investments in that $2 billion I talked about are really expanding our AI-ready portfolio to deliver fully integrated systems that bring AI-powered computing to everywhere data is created, especially the edge, and helping businesses easily and efficiently deploy generative AI applications. We're also hearing that customers want choice. Choice in systems, choice in software, choice in services, and definitely large language models and model training are creating a lot of buzz. But over time, I think we all know inference is going to become the dominant AI workload as data flows from these billions of connected devices at the edge. So generative AI, from our perspective, like you said, I think in your opening comments, needs high-performance compute, large and fast memory, and a software stack to support the leading AI ecosystem solutions. So with that, I believe Lenovo and AMD are really uniquely positioned to take advantage of these trends.
Yeah, absolutely. And our teams are doing a lot of work together and working closely on MI300X. Tell us more about your plans.
Well, we have a long, proven track record as a PC company and as a data center company of bringing Ryzen AI to our ThinkPads. And we're committed to being time to market on large language models, on inferencing, and we're working with AMD to develop our next-gen AI product roadmap and our solution portfolios. So we're incredibly excited today about the addition of the MI300X to the Lenovo ThinkSystem platform. It's going to be very exciting.
Thank you.
So we're committed to be time to market with a dual EPYC 8 GPU MI300X and have a lot of customer interest on that. So bottom line, from edge to cloud, we are incredibly excited about what's ahead from us. We're going to have all of this available as a service through our Lenovo TrueScale as well, so you only have to pay for what you need. So as we move to an as-a-service model, everything we talked about today will be available through that as well. So thank you very much, and look forward to continuing the collaboration.
Absolutely. Kirk, thank you so much. Thanks for the partnership.
All right, thank you.
So that's great. Big thank you to Kirk and Arthur and Charles for all the work that we're doing together to really bring MI300X to our customers. It really does take an entire ecosystem. We're very proud of actually the broad OEM and ODM ecosystem that we have brought together to bring a wide range of MI300X solutions to market in 2024. And in addition to the OEM and ODM ecosystem, we're also significantly expanding our work with some of these specialized AI cloud partners. So I'm happy to say today that all of these partners are adding MI300X to their portfolio. And what's important about this is it will actually make it easier for developers and AI startups to get access to MI300X GPUs as soon as possible with a proven set of providers who each have their unique value and capabilities. So that tells you a little bit about the ecosystem that we're putting together for MI300X. Now, we've given you a lot of information already, but what is very, very important is not just the hardware and the software and all of our customer partnerships, but it's also the rest of the system partnerships. So now let me welcome to the stage Forrest Norrid to talk more about our AI networking and high-performance computing solutions.
Thank you, Lisa. Good morning. So far, we've talked about the amazing GPU and open software ecosystem that AMD is building to power generative AI systems. But there's a third element that's equally important to the performance and scalability of these large AI deployments, and that's networking. The compute required to train the most advanced models has increased by a factor of 50 billion over the past decade. While GPU performance has also increased, what that performance demand means is that we need many GPUs in order to deliver the required total performance. Leading AI clusters are now tens of thousands of GPUs, and that's only going to increase. Well, so the first way we've scaled to meet that demand is within the server. A typical server has perhaps a couple of high-performance x86 CPUs and perhaps 8 GPUs. You've seen that today. These are interconnected with a high-performance, low-latency, non-blocking local fabric. In the case of NVIDIA, that's NVLink. For AMD, that's Infinity Fabric. Both have high signaling rates, low latency, both are coherent. Both have demonstrated the ability to offer near linear scaling performance as you increase the number of GPUs, and both have been proprietary, effectively only supported by the companies that created them. I'm pleased to say that today, AMD is changing that. We are extending access to the Infinity Fabric ecosystem to strategic partners and innovative companies across the industry. Doing so allows others to innovate around the AMD GPU ecosystem to the benefit of customers and the entire industry. You'll hear more about this from one of our partners in a few minutes, and much more on this initiative next year. But beyond the node, we still need to connect and scale to much larger numbers. We need fabrics to connect the servers to one another, welding them into one resource. Now, there are usually two networks connected to each of these GPU servers. A traditional Ethernet network used to connect the server to the rest of the data center traditional infrastructure. And more importantly, a backside network to interconnect the GPUs, allowing them to share parameters, results, activations, and coordinate in the overall training and inference tasks. When we're connecting thousands of nodes like we do in AI systems, the network is critical to overall performance. It has to deliver fast switching rates and very low latency. It must be efficiently scalable so that congestion problems don't limit performance. And in AMD, we believe it must also be open to allow innovation. Today, there are two options for the back-end fabric, InfiniBand or Ethernet. At AMD, we believe Ethernet is the right answer. It's a high-performance technology with leading signaling rates. It has extensions such as RoCE and RDMA to efficiently move data between nodes, a set of innovations developed for leading supercomputers over the years. It's scalable, offering the highest radix switching technology from leading vendors such as Broadcom, Cisco, and Marvell. And we've seen tremendous innovation recently in advanced congestion control to deal with the issues of scale effectively. And most of all, it's open. Open means companies can extend Ethernet, innovating on top as needed to solve new problems. We've seen that from Hewlett-Packard Enterprise with their Slingshot technology, which powers the network at the heart of Frontier, the world's fastest supercomputer, enabling it to achieve exascale performance. And we've seen Google and AWS, who run some of the largest clusters in the world, develop their own Ethernet extensions. And finally, maybe most importantly, we've seen the industry come together to create the Ultra Ethernet Consortium and Standard, where leaders across the field have united to drive the future of Ethernet and ensure it's the best high-performance interconnect for AI and HPC. And we're proud to welcome to the stage today some of those networking leaders. Andy Bechtolsheim from Arista, Jas Tremblay from Broadcom, and Jonathan Davidson from Cisco. Welcome, gentlemen. It's not often that we have such a panel of Ethernet experts on the stage. But before we jump right into Ethernet, perhaps we can talk a little bit about the work of enabling an ecosystem for AI solutions and what that looks like and why is it so important to have an open approach. And maybe, Jonathan, you could start.
Sure, absolutely. Well, first of all, congratulations on all the announcements today. We look at how Ethernet is so critical because I remember back in the day doing testing on 10 megabit Ethernet interoperability. We're now at 400 gig, 800 gig. We have line of sight to 1.6 terabit. It is absolutely ubiquitous across the industry, and it's also interoperable. It's a beautiful thing. So that open standard is really important for us to be able to make this successful.
Absolutely. And Jas, your thoughts as well?
No, I 100% agree. And Forrest, you and I share a vision of the power of the data center ecosystem. You think about a data center, you've got thousands of companies coming together to work as one, and this is really enabled by open standards and a code of conduct that we shall interop. We're going to make things work together across companies, in some cases across competitors. And I'm especially excited about the work that you and I have been doing on Infinity Fabric XGMI.
Right.
And we want to let the industry know that the next generation of Broadcom PCIe switches, which are used as the internal fabric inside AI servers, are going to support Infinity Fabric XGMI. And we'll be sharing more details around that over the next few quarters. But I think it's important that we offer choices and options to customers and that we come together and jointly innovate.
I completely agree. And Andy, you've long been a proponent of open.
Yeah, well, open standards have been the driving force for a lot of the innovation throughout the industry's history. But nowhere this is more true than in the case of Ethernet, where the incredible progress we've seen for the last 40 years would not have happened without the contributions of many, many ecosystem participants, including the companies that are represented here on the stage.
Absolutely. Well, okay, so since this is a panel of Ethernet luminaries, let's talk about Ethernet in particular. What are the advantages of Ethernet for AI? What are the advantages of Ethernet in general? And how are customers using it today? And we'll talk about the future in a minute, but let's reflect on current state. Maybe Andy, you could start out.
Yeah, so Ethernet is, at least to me, is the clear choice for AI fabrics, and for a very basic reason, it doesn't have a scalability limit. It can truly support not just 10,000s of nodes today, but 100,000s, perhaps even 1 million nodes in the future. And there is no other network technology that has that attribute. And without that scalability, you're just boxing yourself in.
Yeah, very true. And Jonathan, I know you guys have been working quite a bit on AI networking systems as well. Maybe you could amplify.
Well, for today specifically, we see the majority of hyperscalers, as you've had some of them on the stage today, are either using Ethernet for AI fabrics, or there's a high desire for them to move to Ethernet for the AI fabrics. And so that requires a lot of collaboration from the folks up here on stage to make that happen. We also have been helping customers deploy in the past their AI networks for enterprise use cases globally. And it might have started more in the financial trading sector in the past, but we're seeing a tremendous amount of interest and use cases for that whole system and how you pull all those things together from the network, the GPU, the NIC, the DPU, all the way to how you wrap the software around that to really make it simple and understand how things are working, and when they're not working, why, and making that simple for them to do that as well.
Yeah, absolutely. And Jazz, I know, well, all of us have been working together in deploying Ethernet-based solutions for AI leaders today. But I mean, we've been working with the two gentlemen on the end on switching, but Jazz, maybe you can reflect on the NIC as well.
Well, I think the NIC is critical. People want choices, and we need to move the innovation even faster in the NIC. And you'll see much more linkages between the NIC and the switch, where before you had a compute domain and a network domain, and these things are really coming together. And AI is a driving force of that because the complexity is going up so much.
Yeah, absolutely. Well, okay, so let's talk about the future a little bit. You know, the Ultra Ethernet Consortium is all four companies on stage are founding members, and there's many others that have joined. You know, UEC is one of the fastest growing, or maybe the fastest growing consortium under the Linux Foundation, which has been great to see. It's going to shape, I think, UEC is going to shape the future of AI networking. And so let's unpack that, because I think that's a critical topic for folks. So maybe, Jazz, why don't you go ahead and start out?
Yeah, so first of all, Ethernet is ready today for AI, but we need to continue to innovate. And UEC started with a group of 8 companies, including 4 of our companies here, cloud providers, system providers, and semiconductor providers, coming together around a common vision. And the vision is AI networks need to be open, standards-based. We need to offer choices, and we need to enhance them. And with that common vision, you know, the engineers we've assigned from other companies really got together and rolled up their sleeves, and the innovation happened extremely quickly. It's quite exciting, actually. And one of the things that I'm most excited about this is we're not building something new. We are jointly going to enhance Ethernet that's existed for 50 years. So it's not starting from scratch, it's enhancing, it's recognizing that Ethernet is what people want. We just need to continue to enhance it and making this open and standards-based.
Absolutely. And Jonathan, I know Cisco's been a huge proponent of UEC as well. Maybe you can reflect on your thoughts of where this is going.
Absolutely. Well, I think that UEC absolutely is very critical for Cisco, everyone on the panel, and the whole industry, so that we can continue to drive that movement towards open. It always takes time. You got to debate what are the right technical way to solve things, but I think that overall it's moving in the right direction. What I see what's happening here is that we're going to have interoperability in more than just one area. You know, Andy, you might want to talk about LPO and all the things that we need to do there to make that actually happen. And what's happening in the UAC is another important part. And what I see what's happening between now and when the first standard comes out is really a coalition of the willing. Like, how do we get all of us together to drive towards those open interfaces, whether it be at the Ethernet layer, whether it be at things that you need to plug into it, how the GPUs connect into that, how you're actually going to spray traffic across a very broad radix, how you're going to make sure you can reorder packets in a consistent way. These are all things that we need to to make sure that we are driving towards from an interoperability perspective. And we've got our own silicon, we've got optics, but we also are in the component business at Cisco. And so we sell those things. Hyperscalers might want to just buy pieces from us, like the silicon, and enterprises may want the full system. But we want to make sure that it's absolutely 100% interoperable in every single environment.
Oh, absolutely. And Andy, maybe you can hone in a little bit more. I mean, I think many people that aren't familiar at all with networking may think, hey, how hard can this be? We're just, you're just shuffling bits around between systems, but there's a lot of problems to solve.
Yeah, so UEC is in fact solving a very important technical problem, which is, the way I would describe it is modern RDMA at scale. And this has not been solved before. To be clear, Rocky today exists, but it has its limitations. And it does take an ecosystem effort approach. It involves in particular the adapter, the NIC silicon vendors, but also the whole end-to-end interoperability of that architecture. And we're very excited to be part of this. We're not in the NIC business ourselves, but this is absolutely key to enable scaling of RDMA across hundred thousands, if not 1 million nodes.
Yeah, absolutely. And when you look at what's being predicted in terms of million node, hundreds of thousands up to 1 million node systems, I mean, we all have our work cut out for us. But working together, I know we can solve the problems. Well, guys, thanks so much for coming to talk to us today. I'd like to thank you all for your partnership in this journey, and thank you all for coming today. Thanks very much. Thanks, guys. Thank you so much, Sean. I'd really like to thank our partners from Arista, Broadcom, and Cisco for attending and for their partnership in driving this critical third leg that determines the performance of AI systems. Now, let's turn our focus to high-performance computing, the traditional realm of the world's largest systems. AMD has been driving HPC technology for many years. In 2021, we delivered the MI250, introducing third-generation Infinity architecture. It connected an EPYC CPU to the MI250 GPU through a high-speed bus, Infinity Fabric. That allowed the CPU and the GPU to share a coherent memory space and easily trade data back and forth, simplifying programming and speeding up processing. But today, we're taking that concept one step further, really to its logical conclusion, with the fourth generation Infinity architecture bringing the CPU and the GPU together into one package, sharing a unified pool of memory. This is an APU, an accelerated processing unit. And I'm very proud to say that the industry's first data center APU for AI and HPC, the MI300A, began volume production earlier this quarter and is now being built into what we expect to be the world's highest performing system. Now, Lisa already showed you what our chiplet technologies make possible with the MI300X. The MI300A takes those same building blocks in a slightly different fashion. Now, the I/O die is laid down first, as before, and contains the Infinity cache and connections to memory and I/O. The XCD accelerator chiplets are bonded on top, as in the MI300X. But with the MI300A, we also take CPU chiplets, leveraged directly from our fourth generation EPYC CPUs, Genoa, and we put those on top of the IODs as well, thus bringing together our leading CPU, Zen, and CDNA technologies into one amazing part. Finally, 8 stacks of HBM3 with up to 128 gigs of capacity complete the MI300A. A key advantage of the APU is no longer needing to copy data from one processor to another, even through a coherent link, because the memory is unified, both in the RAM as well as in the cache. The second advantage is the ability to optimize power management between the CPU and the GPU. That means dynamically shifting power from one processor to another, depending on the needs of the workload optimizing application performance. And, very importantly, an APU can dramatically streamline programming, making it easier for HPC users to unlock its full performance. And let's talk about that performance. 61 teraflops of double precision floating point, FP64, 122 teraflops of single precision. Combined with that 128 gigabytes of HBM3 memory at 5.3 terabytes a second of bandwidth, the capabilities of the MI300A are impressive. And they're impressive too when you compare it to the alternative. When you look at the competition, MI300A has 1.6 times the memory capacity and bandwidth of Hopper. For low precision operations like FP16, the two are at parity in terms of computational performance. But where precision is needed, MI300A delivers 1.8 times the double and single precision FP64 and FP32 floating point performance. And beyond simple benchmarks, the real advantages of an APU come with the performance of real-world applications which have been tuned for the APU architecture. For example, let's look at OpenFOAM. OpenFOAM is a set of computational fluid dynamics codes widely used across research, academia, and industry. With MI300A, we see 4 times the performance of Hopper on common OpenFlow codes. Now, that performance comes from several places. From higher performance math operations, as we talked, larger memory, and the increased memory bandwidth. But much of that uplift really comes from that unified memory eliminating the need to copy data around the system. That can perform, for tuned applications, truly transformative performance. And I'm also proud to say that beyond performance, AMD has stayed true to its heritage, to its history of leading in power efficiency. At the node level, the MI300A has twice the HPC performance per watt of the nearest competitor. Customers can thus fit more nodes into their overall facility power budget and better support their sustainability goals. With the MI300A, we set out to help our customers advance the frontiers of research, and not just running traditional HPC applications. One of the most exciting new areas in HPC is actually the convergence with AI, where AI is used in conjunction with HPC techniques to help steer simulations, thus getting much better results much faster. A great example of this is CosmoFlow. It couples deep learning with traditional HPC simulation methods, giving researchers the ability to probe more deeply and allowing us to learn more about the universe at scale. CosmoFlow is one of the first applications targeted to be run on El Capitan, which we believe will be the industry's first true 2 exaflop supercomputer running double precision float when it's fully commissioned at Lawrence Livermore National Labs. Now, it's going to be an amazing machine. So let's hear more about El Capitan and its applications for HPC and AI from our partners at LL&L and Hewlett-Packard Enterprises.
We expect El Capitan to be an engine for artificial intelligence and deep learning. We will recreate the experimental environment in simulation, generate lots of data, for example, and then train our artificial intelligence methods on that simulation data. El Capitan will be the most capable AI machine, and its use of APUs at this scale will be the first of its kind.
As you operate these exascale level workloads, all of those nodes talk to each other. AMD and HPE have a long legacy of partnership, and it was only natural for us to partner again for El Capitan. The MI300A can be versatile across many different workloads, and we couple it directly with our Slingshot fabric to give it high performance as it operates as a system.
We work very closely with AMD and HPE to deliver the hardware and the software that's actually used by the scientists in the machine itself.
It's really that partnership together that can really go after and build these supercomputers.
El Capitan will be 16 times faster than our existing machine here at Lawrence Livermore. It will enable scientific breakthroughs that we can't even imagine.
We're proud to have partnered with Hewlett-Packard Enterprises to design and now build this amazing system. And so I'd like to invite to the stage Trish Jamkerger, the Senior Vice President and Chief Product Officer for HPC, AI, and Labs from Hewlett-Packard Enterprise. Welcome, Trish. You know, the AMD and HPE teams have been working closely together over the years to deliver some next-generation supercomputers. You know, most recently, of course, we've broken the exascale barrier. I got to say that again. We broke the exascale barrier with Frontier for Oak Ridge National Labs, and now we're looking forward to powering another exascale system and another record. With you with El Capitan for Lawrence Livermore National Labs, another U.S. Department of Energy lab. Maybe you can share more with this audience about our journey together and the innovations that we've ushered in this journey to exascale.
Sure. First, I want to echo the long partnership that we've had with AMD. Frontier continues to be the fastest computer in the world. Many doubted our ability to actually reach exascale, but we were able to achieve this feat with industry-leading liquid cooling infrastructure, next-generation high-performance interconnect with Slingshot, our highly differentiated system management and Cray programming environment software, along with the incredible MI250. With Frontier, exascale computing has already made breakthroughs in areas such as aerospace, climate modeling, healthcare, and nuclear physics. Frontier is also one of the world's top 10 greenest supercomputers. In fact, HPE and AMD have the majority of the world's top 10 energy-efficient supercomputers. I know. I am very excited to deliver El Capitan to Lawrence Livermore. As you know, I worked there for over 15 years. El Capitan's computing prowess will fundamentally shift what the scientists and engineers will be able to achieve. El Capitan is going to be 15 to 20 times faster than their current system. Supercomputing is truly essential to the mission of the Department of Energy. Lawrence Livermore has been at the forefront, driving the convergence of HPC and AI, demonstrated by work at the National Ignition Facility and other of the national security programs. I'm really looking forward to continuing our journey of bringing more leadership class systems to the world.
Absolutely. I couldn't agree more, Trish. It's been a rewarding journey working together with HPE. But speaking of our shared success in building these record-breaking systems, can you tell us a bit more about El Capitan and how HPE is developing the Instinct 300X, 300A powered CPU to El Capitan?
Great. Yes, El Capitan will feature the HPE Cray EX supercomputer with the MI300X accelerators to power large AI-driven scientific projects. The HPE Cray EX supercomputer was built from the ground up with end-to-end capabilities to support the magnitude of exascale. El Capitan nodes include the MI300A coupled with our Slingshot fabric to operate as a fully integrated system. Supercomputing is the foundation needed for large-scale AI, and HPE is uniquely positioned to deliver this with our Cray supercomputers. El Capitan will be that engine for AI and deep learning for the Department of Energy. They will be recreating the experimental environment and simulations and training the AI models with all of that vast amount of data. El Capitan will be one of the most capable AI systems in the world. And beyond El Capitan, we're excited to have expanded our supercomputing portfolio with the MI300A to bring next-generation accelerated compute to a broad set of customers.
Yeah. So Trish, it's fantastic. And actually, let's double click into that a little bit more. I know that there are a growing number of supercomputing customers, not just at LLNL, that are really applying AI to their projects. Can you tell us a little bit even more about that?
Sure. So AI undoubtedly will be the catalyst to transform scientific research. As I said earlier, supercomputing is the foundation needed to run AI, and HPE is the undisputed leader in delivering supercomputers. Some example where AI will be fundamental in El Capitan include the National Ignition Facility, where they will be using 1D, 2D, 3D simulations along with trained AI models to develop a more robust design for higher yield fusion reactions. Just imagine fusion energy in our future. Another application is high-resolution earthquake modeling, essential for understanding building structural integrity and also emergency planning. And one more application is bioassurance, where simulation and AI models will be key in developing rapid therapeutics. Supercomputing and AI are tools to allow engineers and scientists the ability to find the unknown. I'm thrilled to be part of the journey of accelerating scientific discovery and the scale of impact it has on changing the way people live and work.
Fantastic. Well, Trish, thank you. I'm so excited about the opportunities that researchers and scientists will have with the systems that we're bringing to the market together. Thanks so much.
Thank you.
Yeah, on behalf of AMD and the entire team, I really want to just thank HPE and our customers for the opportunity to participate in the development of these massive systems. Because El Capitan will be an amazing machine and a real showcase for the MI300A, which defines leadership at this critical juncture as HPC and AI converge. AMD is proud of the leadership systems powered by MI300A, which will be available soon from partners around the world. I can't wait to see what researchers and scientists are going to do with these systems. And with that, I'd like to welcome Lisa back on stage to conclude our journey today. Thank you.
All right, thank you, Forrest, and thank you to all of our partners who joined us. You've heard from Victor, Forrest, our key partners. We have significant momentum, and we're building on that for the data center AI platforms. To cap off the day, let me now talk about another important area for AMD where we're delivering leadership AI solutions, and that's the PC. Now, for the PCs, we recognized several years ago that on-chip AI accelerators, or NPUs, would be very, very important for next-generation PCs. And the NPU is actually the compute engine that will enable us to reimagine what it means to build a truly intelligent and personal PC experience. At AMD, we're on actually a multi-year journey. We have a strong roadmap to deliver the highest performance and most power-efficient NPUs possible. We were actually the first company to integrate an NPU into an x86 processor when we launched Ryzen Mobile 7040 series earlier this year, and we integrated the XDNA architecture that actually came from our acquisition of Xilinx. It actually took us less than a year to bring Xilinx's proven technology into our PC products. Let me tell you a little bit about XDNA. It's a scalable and adaptive computing architecture. It's built around a large computing array that can efficiently transfer the massive amounts of data required for AI inference. And as a result, XDNA is both extremely performant and also very energy efficient. So you can run multiple AI workloads simultaneously in real time. Now, I'm happy to say that we've already shipped millions of Ryzen AI-enabled PCs into the market with all of the leading PC OEMs. And all of this provides the hardware foundation for developers to leverage this first wave of AI PCs. Now, if you look at some of the applications, today Ryzen AI powers hundreds of different AI functions, things like advanced motion tracking and sharpening to deblur 4K video, enabling production-level digital production capabilities with unlimited virtual cameras, all in an ultra-thin notebook for the very first time. We're also working with key software leaders like Adobe and Blackmagic, and they're using our on-chip Radeon GPU to accelerate the AI-enabled editing features so that you can dramatically improve productivity for content creators. And of course, we've worked very, very closely with Microsoft to enable Windows 11 Studio effects on Ryzen AI. Now, today, we're launching some additional capabilities. So Ryzen AI 1.0 software, it will make it easier for developers to add advanced Gen AI capabilities. So with this new package, developers can create an AI-enabled application that's ready to run on AI hardware, on Ryzen AI hardware, just by choosing a pre-trained model. So for example, you can choose one of the models that are available on Hugging Face, quantize it based on your needs, and then deploy it through Onyx Runtime. So this is a major step forward when you think about the broad ecosystem that wants to run AI apps for Windows, and we can't wait to see what ISVs will do when they really capture the leadership performance that you can get from an NPU in Ryzen AI. Now, of course, we know developers always want more AI compute. So today, I'm very happy to say that we're launching our Hawk Point Ryzen 8040 series mobile processors. And thank you. Hawk Point combines all of our industry-leading performance and battery life, and it increases AI TOPS by 60% compared to the previous generation. So if you just take a look at some of the performance metrics for the Ryzen 8040 series, if you look at the top of the stack, so Ryzen 9 8945, it's actually significantly faster than the competition in many areas, delivering more performance for multi-threaded applications, 1.8x higher frame rates for games, and 1.4x faster performance across content creation applications. But when you look at the AI improvements of Ryzen 8040, you really see some substantial improvements. So I talked about additional TOPS in Hawk Point, and what that results in faster performance when you're running the key models. So things like Llama 2 7B, we run 1.4x faster, and also 1.4x faster on things like AI image recognition and object detection models. So all of this, what does it do? It provides faster response times and overall better experiences. Now, I really believe that we're actually at the beginning of this AI PC journey, and it's something that is really going to change the way we think about productivity at a personal level. So we've been working very closely with Microsoft to ensure that we're co-innovating across hardware and software to enable those next generation of AI PCs. To share more about this work, I'm pleased to welcome Pavan Davaluri, Corporate Vice President of Windows and Devices at Microsoft, to the stage. Hey, how are you?
Great to be here.
Pavan, thank you so much for being here. We started the show with Kevin Scott talking about the great partnership between Microsoft and AMD and all the work we're doing on the big iron and the cloud and Azure. Yeah. And it seemed fitting that we close the show with the other very, very important work that we're doing together on the client side. So can you tell us a little bit, Pavan, about all the great work and your vision for client AI?
For sure. As you and Kevin covered, Microsoft and AMD have a long partnership together across Azure and Windows. And it's incredible to see us moving that partnership together into the next wave of technology with AI. As you shared, Lisa, for us, there are millions of PCs right now with Ryzen 740 AI in market. And that's amazing because these are the first x86 PCs with integrated NPUs, enabling enhanced AI experiences.
You told me everybody wanted NPUs.
Absolutely. I mean, right now we get to see some incredible AI features.
Yes,
some you talked about, Windows Studio effects coming to life across the scale of the ecosystem. Absolutely fantastic, I would say. Now, for us at Microsoft and for the ecosystem, our marquee AI experience is really Copilot. Similar to how the Start button is the gateway into Windows, the Copilot for us is the entry point into this world of AI on the PC. And it has a fundamental impact on everything we will do on a computer, from work and school and play and entertainment and creation.
I completely agree, Pavan. I think Copilot is so transformational. I mean, for everyone who's had a chance to experience it, it really changes the way we do work. So let's talk about the tech that's underneath it, so to enable Copilot and everything that we want to do on PCs.
We are putting together new systems architectures that really power those experiences going forward, and they really pull together GPU, NPU, and certainly the cloud as well. And quite honestly, we're seeing customer habits change early at this point in time, and we believe, to your point earlier, we're early in the cycle of innovation that's coming. When we have these powerful NPUs like the ones you're building, it gives us an opportunity to create apps that take advantage of both local and cloud inferencing. And to me, that's what the Windows AI ecosystem is about, and that's what we're building in partnership with you. It's designed to enable those scenarios with the Onyx runtime, of course, and the Olive toolchain to back us up. Applications are going to have many models, like Llama that you mentioned, Phi 2 running, and they will run very capably in the tops that we will have. And of course, not to mention the foundation models that are powered by the GPUs in the cloud.
Yeah, I mean, I think this is an area where Microsoft and AMD really have a very unique position because, you know, we have so much capability in the cloud. We have also access to the client and the local view. Can you share a bit about how we're thinking about, you know, across all of these, the cloud local view?
Yeah, with AMD, we're making it simpler to incorporate what we call the hybrid pattern or the hybrid loop into applications. And we want to be able to load shift between the cloud and the client to provide the best of computing across both those worlds. For us, it's really about seamless computing across the cloud and the client. It brings together the benefits of local compute, things like enhanced privacy and responsiveness and latency, with the power of the cloud. High-performance models, large data sets, cross-platform inferencing. And so for us, we feel like we're working together to build that future where Windows is the destination for the best AI experiences on PCs.
Yeah, no, I think that sounds great. Now, one of the things, though, that you know, you definitely are always talking to me about is more tops. Pavan asks for more tops all the time. So look, we completely believe that to enable, you know, your vision for AI experiences, you know, we've really thought about how do we actually accelerate our client AI roadmap. So I want to share a little bit of our roadmap today. You know, Ryzen 7040 and 8040, you know, we've already delivered those industry-leading NPU capabilities. But today, I'm very excited to announce that our next-gen Strix-Point Ryzen processors will actually include a new NPU powered by our second-generation XDNA architecture coming in 2024.
Congratulations.
Thank you. So a little bit about XDNA 2. You know, it's designed really for leadership Gen AI performance. It delivers more than 3 times the NPU performance of our current Ryzen 7040 series. And Pavan, I'm very happy to share. I know your teams already know this because you have the silicon, but today Strix-Point is running great in our labs, and we're really excited about it. Our teams have been working really closely together to make sure that all of those great future Windows AI features run really well on Strix-Point. So I can't wait to share more about that later this year.
Lisa, that's awesome, and we will use every top you will provide us.
You promise, right?
Absolutely. And you know, it's not just the size of the neural engines, the dramatic increase in efficiency, performance per watt of these next-generation NPUs, we think will bring a whole new level of capabilities to the market, enabling personalization on every interaction on these devices. Together with Windows, we feel like we're building that future for the Copilot, where we will orchestrate multiple apps, services, and across devices, quite frankly, functioning as an agent in your life that has context and maintains context across entire workflows. So we're very excited about these devices coming to life for the Windows ecosystem. We were excited to see what developers will do with this technology, and quite frankly, at the end of the day, ultimately, what customers will do with all of this innovation.
Thank you so much, Pavan. We are so excited about the partnership. We appreciate, you know, all the long-term work we're doing together, and look forward to lots of great things to come.
Thank you for having me, Lisa.
Thank you, Pavan.
Thank you.
All right, so it's been such a fun day, but now it's time for me to wrap up a bit. We've showed you a lot of new products, a lot of new platforms, a lot of new technologies that are all about taking AI infrastructure to the next level. MI300X, MI300A accelerators, these are all shipping today in production. They're already being adopted by Microsoft, Oracle, Meta, Dell, HP Enterprise, Lenovo, Supermicro, and many others. You heard from Victor how we're expanding the ecosystem of AI developers, working with us, ROCm 6 software, the open ecosystem, that our goal is to make it incredibly easy for everyone to use Instinct GPUs. You heard from Forrest in our panel on the overall system architecture, our work with Arista, Broadcom, and Cisco. We believe that to create this high-performance AI infrastructure, it has to be open. And that's what we're doing together for scale-out AI solutions. And then you heard what we're doing on the other side, the client part of our business, because we actually believe AI should be everywhere. So our latest Ryzen processors really extend our compute vision and our AI leadership. I hope you can see that AI is absolutely the #1 priority at AMD. Our goal is to push the envelope, to bring innovation to the market, to do more than anything thought was possible, because we believe, as wonderful as our technology is, it is about doing it together in a partner ecosystem where everybody brings their best to the market. Today is I want to say on a personal level, today is an incredibly proud moment for AMD. If you think about all of the innovation, everything that we bring to the market, to be part of AI at this time, at the beginning of this era, to work with these amazing people throughout the industry, throughout the ecosystem at AMD, I can say that I've never seen something more exciting. A very, very special thank you to all of our partners who joined us today, and thank you all for joining us.